In this third example, we will try to plot V1, which is 35 exponential negative t, and so on. So this is the voltage across the inductor. So it is taken from this example. Okay, you can try to solve this using Laplace transformation. But for this example, this is the V1. I will try to plot this V1, okay, using Matlab. So let's do that. All, close all, CLC. Okay, so what's the signal? What's the equation? V 35 times exponential of negative t minus 30 times exponential of negative 2t. Alright, 35, 30 minus 2. Alright, so this is this is the equation, right? Before that, that is alright. What is t here? T is I'm just going to put the value negative 0.25 increment increasing by 0.001 up to 0.25. okay, the same t for in the previous example. Alright, so we have t v1, so that's it. Actually, we can now plot the signal. So let's plot the signal. What is x-axis? X-axis is the t, y-axis is the v1. And let's put some label x, that is the time, right, in second. Y label is in voltage. So let's plot that. So this is the signal, right, from negative 0.25 to 0.25. However, if you look at the question, look at the answer, it's actually a signal of ut. It's a ut. So meaning that the signal only exists for during the positive time, positive part of the plot. Less than 0 is 0 value, right? It's 0 voltage. Okay, before 0 second is 0 voltage, and after 0 second, for the positive second, it will have this plot. So it's actually from here 0, from here 0, this is 0 here, up to 0 second, you jump up to here. So that is the actual plot, the actual answer for this signal. But it will be quite difficult to plot that. You can just simply change this to 0. Alright, that's the plot, right, from 0 to whatever value. Alright, that's the plot. But you can make it more complicated, right? If you really want to see the signal in negative side of the plot. So what we can do here is actually going to write some if-else statement, right? So if the time is less than 0, then v1 is 0, right? Else v1 is this equation, right? And however, we need to also need to use for x, okay, from 1 to the length of t, right? So first, because we have so many t values here, alright, we have so many t, okay, so which t is we actually refers to, so we have to tell that the first one, which is 1 to total length. Okay, if we use for, we have to put n here, right? This n refers to the for, this n refers to if else. Alright, so for the first t, if it's less than 0, v1 is 0, else is this equation. So t, we have to let the Matlab know t is actually refers to which t. T is actually refers to the x, which is 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7, 8, and so on until here we have 251 numbers, right? So let's try this if it's working. So actually I forgot to put the x here. Alright, so x is from 1 to 501, so it's we will calculate v1 for 1, 2, 3, 4 until 501, which actually refers to the t, right? T is negative 0.25 increased by 0.01, so increase by 0.01 until it reached to 0.25. So from here to here contains 501 increment. So for the first x, for x1, which is t1, which is negative 0.25, we will calculate the value and it will do the loop, increase 1 by 1, and then calculate the v. So that's it. Let's try to run this. So that's the answer. Okay, for less than 0 is for less than 0 second is a 0 voltage. Higher than 0 second is there's a value, and this is actually from this equation.